Okay, anyways. Huh? We'll have the second class this morning as a test.
Second class this morning is next second.
You have a double class now. Yeah, so the second of these two classes. Yeah. Right, what was I saying? Oh yeah, so last time we were looking at Pascal's triangle as a way to expand. But there is another way that's actually a little bit better than Pascal's triangle. So what would be one disadvantage of Pascal's triangle?
For large numbers, it's not helpful.
For large numbers, Pascal's triangle is a problem. Why?
Because you have to keep drawing the triangle.
You have to keep drawing the triangle. Keep going down. So, before we start looking at alternatives, what we're looking at now is called the Binomial Theorem. Now, just before we start, has anybody seen what this means before? Very good. It's called a factorial. 4 factorial. And what does it equal? 4 times 3 times 2 times 1. So that's 24, isn't it? 3 factorial, which is 6. 2 factorial, which is 2 times 1, which is 2. 1 factorial, which is 1. And 0 factorial, which is
1.
0, 1, 0. It's 1. Okay, so just note this one, please, to be careful. Okay, so this is factorial, so this will actually be useful. So using factorial, we can make a new function called, I call it C or choose. So if I write something like this, NC or, yeah, that's n factorial over or factorial n minus or factorial. Yeah. Please also note, come on, hurry up. In China, and maybe some other countries as well, the or and the n is backwards. In some places the or and the n is put in front. And in some places we can write the or and the n like this. But this is not the way I do it. I keep it like this.
Okay.
In the exam they use this. No, I don't even think they do use that. This one for the exam. So let's have a look at a simple example. So suppose I have something like 4C2. That would be 4 factorial over 2 factorial, 4 minus 2 factorial. That would be 4 factorial over 2 factorial, 2 factorial. It should be 24 over 2 times 2, which is 6 then. Final answer. But what I want you to look at now is your calculator, because on your calculator there's an NCOR button, so you could type in 4 NCOR and 2, and just check that you do also get 6. Usually this is on the divide or multiply key, sometimes it's on the 9 or 0 key. You got 6, yeah. Okay, I'll just give you a second and then I'll scroll down. It's sometimes on multiply, divide, 9 or 0, or 3 or 6.
Does it have a
hand me the calculator. Hand me the calculator. Keep it coming. I said it's on the multiply, divide, 9 or 0, 3 or 6. Is it on any of that? What button is it on?
It's on divide.
Funny, that's what I said it might be on divide.
You said divide 9 or 6.
Right. Did you write that down?
everything at 3, so how do you do that?
Oh my goodness! Just type in what I wrote here, 4 NCR button 2.
I'm sorry.
Where's the NCR?
Alright, just don't do this question in the exam, okay? Yeah. Right, I'm moving on now. So use your calculator. I want you to calculate 1C1. So you get 1 here. Okay, so let me just then have you doing 2 C1 and 2 C2. So far you have, oh my goodness, so far you have 1, 1 and 1, don't you?
Yeah.
And then let's do another few, 3C1, then 3C2, and then 3C3. So for the first one, I think you should get 1. Then when you type in the next one, you get 2, 2.
3C1 is 3.
3C2 is
No, 3C1.
No.
3C1 is 3.
C1 is 3.
3.
Is this?
3C1 is 3.
Then something went wrong. Oh, maybe.
2C1 is 2, isn't it?
Oh, do you know what? Sorry, that's not what I want you to do. Well, you can do that one as well. This is not how I remember it. Oh, that's right. I want the zeros as well. Yeah. Thank you. I didn't drink enough coffee yet. Right. Okay, so these are the ones I want you to calculate. Give me 0C0 and then, actually this might not even work on your calculator. Did it work? Alright. And then 1C0 and then 1C1, 2C0, 2C1, 2C2. Okay, so the first one here was 1 and this is still 1 and 1, and then this should be 1 and 2 and 1. Yeah? What you'll notice happening, if I do 3C0, 3C1, 3C2, 3C3, if you calculate those on your calculator, you'll get 1, 3, 3, and 1. So what's happening here? We're getting the triangle. So if you want, you can use this here to calculate the number in Pascal's triangle on row n and column or. So for example, this is the second row. Well, actually, yeah, it's the second row. And just remember for this, what I forgot actually, is we start counting at 0. Okay, so this is actually 0, 1, 2, third row. And then, for example, here this is 0, first, second, third column. So this would be row n and column or. So for example, 5C3 would be go 1, 2, 3, 4, 5. Sorry, I forgot what I just said 1 second ago, starting at 0. 0, 1, 2, 3, 4, 5, and then 0, 1, 2, 3. So you can use this to make any value on the triangle without needing to make the triangle. So it's very, very convenient, very, very useful. So what we're going to do is we're going to use this for more difficult expanding problems, okay? I don't know if you even just want to write this much down, this box here. This is really the key. Question? I'm missing like 4 people, isn't it? Or 5 people. Juliana and... Oh yeah, Turkey, yeah. Who? Do I know this person?
Yes.
Not Mocha, it's different.
Do they give me trouble in class?
No.
Alright, fine, yeah.
More.
Good or bad?
Magnetic.
Don't know yet, too early to say, is it? And who else? Okay. Oh, I got an email from her, yeah. Okay, can I continue now? So let's have a look at some examples using this to expand. So this is nice. You don't need to use Pascal's triangle if you want to expand. So for example, if I have something like this, minus 2x plus, let's say, y cubed. Okay, so what we do, we are looking at row 3. So we have 3c0, that's the first entry in the row. And then here would be minus 2x, and here would be y. Yeah. And we'll put the powers in a moment. The next one would be 3c1 minus 2xy, and the next one is 3c2, 2x and y, and then finally is 3c3. Well, you know what? I'll just put it in on the next line. Plus 3c3 minus 2x and y. And there's a 1 here. Now let's put in the powers. And again, it doesn't matter which way around you put them. So for example, if I put a 0 here, then this one needs to be a 3, and then that would be a 1 and a 2, a 2 and a 1, a 3 and a 0. 3c0 is 1, and this is 1, so it starts off with y cubed. That's a 3 and a minus 2, so that's a minus 6. That's a 3 and a 4, so that's 12. That's a 1, that's a minus 8. So this is the answer then. So now we're starting to get very quick at expanding. Yeah, but I don't need to go to the trouble of writing down the formula, because it's more just we're using the formula, but I feel like I'm complicating things by writing it down. So there's just a process, the way I think about it. You start with 0, and you have the third row because of the third power, and you just go through it one by one.
Only it's b minus 1, b minus 2 on top, right?
Ah, yeah, but our life is difficult enough. Trust me. We don't need to make it more difficult. Yeah? Okay. Let me give you a small one like this just to practice expanding. So just try something, I don't know, something like x plus 2y. Yeah, we'll keep it simple for you. We'll say squared. I want you to use the c's to expand it. Okay, so you should be finished. It's pretty quick to do. So we have, what's the first part? 2c0 x 2y, yeah, plus 2c1 x 2y plus 2c2 x 2y. So this will be, we'll do 2 here. 2, 0, 1, 1, 0, 2. Right, so that will be x squared plus 4xy plus 2 squared is 4y squared. That's the answer then. Okay, so we'll start looking at more difficult examples, but this is just to give you the basic idea. In the exam, they'll say expand using Pascal's triangle, or they might say expand using binomial coefficients or binomial function or the C function. They usually don't. 90% of the time when they pick a method for you to use, they pick Pascal's method. Okay? Come on. No, this is, I believe, 4xy, because this is a 2 and this is a 2. Yeah. So we have, let's see, where's my pen gone? Come back. Yeah, this 2 here and this 2 here is making this 4 here. Yeah. Okay, shall we look at something a little bit more difficult now? Scrolling down. So one big advantage of this method is that you can jump straight to any term. So for example, I could say, what is the coefficient of x, let's say x7 in, let's say, 2x plus y power 10. And for those who don't know, coefficient means the number in front of the x. So for example, if I have a xn, the a is called the coefficient, not the x part. Right, so you might think, oh, if to find the x7 I need to expand everything, but I don't. I can just jump to the x7. So you know your answer will have many terms, ... plus the one we care about, plus many more. So let's look at the one we care about. We know that it will always have 3 parts. It will have a c, a bracket 2x, oh sorry, that shouldn't be a y, just change that to a 4, plus, sorry, 2x and bracket 4. We know it'll always have this in it, a c, a 2x and a 4, because that's a 4 there. So we need to think carefully about what numbers to put in. Well, we know what this number is. What number is this? No? 10, because it's power 10. Yeah. And since we're looking for the 7th column, this will be a 7 here. We want x power 7. So should I put the 7 on this one or the second one? On the first one, which means this has to be 3, because it still needs the total 10. Yeah. So in fact, I don't care about the x part, it's only the non-x part I care about. So on my calculator I can type in this, 10c7, 2 power 7, 4 cubed, yeah? You have the answer? Not yet? Okay. 7680. That would be the coefficient of x power 7. No? Okay, fine, go ahead. 983040. Yeah. And that would be the coefficient of x power 7. So in the middle of your expansion you would have something like this. But remember, coefficient means only the number, so I only report this as the answer. Sometimes students write this in the exam, and I don't know. If I'm having a bad day, maybe I'll take a mark away from you, because this isn't really what you were asked for. You were just asked for the coefficient. So just be careful about that. Okay. Right, let's have a look at another example of another way we can use this. I should also say, actually, this is a pretty common question in the exam. And also in the exam, what they sometimes like to do, you don't need to write this down, but I'll show you. What they sometimes like to do in the exam is they like to leave one of these numbers as a constant. So I'll call it like, I don't know, C. Or no, C might be confusing. I'll call it like P. So that means instead of a 4 here, it would be a P. And then they would say the coefficient is 9830440, find P. So you just have to then solve this equation for P. It's no big deal, but it's just the slight ways that they can reword the question. Okay, let's have a look now at something a little bit more difficult. So also another type of question in the exam is they ask you to expand something big, but they don't want all of it, they just want maybe the first three terms. So let's just do something like expand, let's say, 2 plus 3x power 10 up to the third term, and we'll have it two ways. My pen hasn't caught up with me yet. Can hear it working. Still working. No. Oh, there we go. Right, so expand up to the third term, and the two possibilities are ascending and then descending. So ascending powers or descending powers. So ascending means this way and descend means this way. Okay, if you write this down, and then what I'll do is I'll do the first part and then I'll let you try the second part. So I'll do part A first. So we will expand 2 plus 3x power 10 ascending powers. Yep, let's have a look. So I know I only want the first three terms, so I'll have c 2 3x plus c 2 3x plus c 2 3x, and then there are many other terms which we won't find. Now I have to be careful because the question says ascending powers, so it means the powers are going up. So I should start at 0 here. 1, 2. And so what's this?
10.
10, 9, and 8. So this will be 10C0, 10C1, 10C2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. 1024 plus, and this will be 10 times, is it 5,120 for the next one? I'll just wait until you work it out on your calculator. No, it's not actually, because I forgot the 3, so it should be 15,360.
Yes.
Great. 15,360x. Right, 256 times 9. Okay, no, I give up now for the last one. Right, so the last one, please. Okay. So there are the first three terms in this expansion. So now I want you to try and do this descending powers. Okay, we have this one done. C 2 3x plus C 2 3x plus C 2 3x. Okay, so again, it's still the same coefficients, 10C 0, but if you want you can put in 10C, 10, 9 and 8, that's fine. But you get the same numbers on the C function. So this time this would have to be a 10, a 9 and an 8, and so this would have to be a 0, a 1 and 2. So what did you get for the first one? Let's have a look. It should be quite big. 59049 plus, yeah, good question. What about the x? X10 plus 399 393 x9, and then finally x8. Yep.
Isn't there a way when you do it when A is not 1, you take the 2 out?
I don't know what you're asking me, but yes. Yes. Because usually when students have a question, isn't there another way to do this, or isn't there a way to do it? The answer is yes. Yes, there is. And there's a good reason maybe I didn't say it. Because again, making the life easier, okay? Alright, did you write this one down? Yep. Right, so let's have a look at now an even more difficult example. So if I can scroll down. Okay, so in yeah. Yes. Do you want me to go back a sec? Yeah. Shh. I can't hear the question. Be quiet. Hang on a second. There's a student being stupid here. And the reason I say they're being stupid is because if they continue talking, they're going to get a slap in the face. So, which student is being stupid? Or maybe I misheard. I misheard. Please continue with your question.
In this question, the coefficients, are they not going like from the smallest to the biggest? Because
which coefficients are the C's or?
no, the answers.
Oh, I see.
Coefficients of the S.
You're noting that they're going from small to big,
Yeah.
but you feel like because the power's starting at 10, it should be going the other way, isn't it? Yeah, that's good. I think the reason that it is happening like that, let's see, it's, oh yeah, no, that's interesting. Yeah, the powers are getting, the coefficients are getting bigger. I don't think that, I wouldn't think that's anything of any problem. You know what's probably happening here? I know that the numbers 2 and 3 are small, but the number 10C9 and 10C8 is quite large. So I think that's what's dominating in the calculation. So when you calculate it, the 2 and 3 are quite small, so they don't contribute as much to the calculation as the C does. So this is why they're getting bigger, is because the C's are getting bigger, and they're getting bigger faster than the other parts are. So this is the reason why, I think, because of the C. Yeah. I think if it was a smaller power, like maybe if this was a power, say, 3 question, then maybe it wouldn't be like this, because then the C's would be small, you know. Okay, let's have a look at another example. Yeah. Yeah.
1 to 10, there's a pattern. At the beginning, the first 3
Yeah.
usually almost the same as the last 3.
They're always the same, yeah. For Pascal's, it's the same for Pascal's triangle, and for this, the first term is the same as the last term. So it's symmetric, yeah. So like if this is a 1, this is a 1, and the next one is 10C1, that's a 10. And the second last term is 10C9, and that's also a 10. So it's always symmetric like this. Okay. Right, let's have a look now. let's say px plus q power 5 equals x5 plus 15x4 plus 90x cubed plus dot dot dot. Okay. So this one's actually interesting because what's happened here is that you have the answer after you expand and you need to work out what the original was, the original binomial. So if you had px plus q power 5, that would equal 5c0 px bracket q plus 5c1 px q plus 5c2 What's wrong? 5 power 5 5c0 5c1 5c2. Now I'm trying to match my calculation up with the answer. So if I'm trying to do that, then I have to put what power here? If I want my first term to be the first term in the answer, this would have to be a 5, and so this one would have to be 0, 4, 1, 3, 2. Okay, so let's simplify this a little bit. 5c0 is 1, so that would be p5x5 plus 5p4q x4. Now what's 5c2? Anybody got 5c2 please?
10.
Is it?
10.
Thank you. Plus 10 p cubed q squared x cubed plus dot dot dot. So what you're doing is you're making a comparison. You know that the first term here, what value should this be if you compare it with your answer?
1.
It should be 1. And this next value, this next coefficient should be 15. And finally, this last coefficient should be 90. So you can make 3 comparisons. You say, we need P5 to equal 1. We need 5P4Q to equal 15. And we need 10P cubed Q squared to equal 90. Now in fact you have more than you need here because we only are looking for 2 things, and the first one is pretty clear. If I need p power 5 to equal 1, then what is p? It has to be 1. So now if p is 1, this becomes 5q equals 15, which means that q should equal 3. And I'm finished. I don't need to continue because I have p and q, but I can confirm my answer is right. So 10, 3 cubed, no sorry, p is 1, so 10 times 1 cubed, 3 squared, does that equal 90? And the answer is yes. So I found my p and q, it is 1 and 3, so we expanded 1x plus 3 to the power of 5. That was the original binomial. Want me to check something?
Sorry, I will raise my cousin.
You need to give that? Go ahead. Maybe the other way would be safer. Okay, did you write that down? Yeah. Okay. Right, we'll do one more example. I'll let you try it first. It's very similar to this one, but more difficult. I want to see if you can do it. So the reason I'm saying it's more difficult is because there are 3 things to find now. In this one we have to find P and Q, But now, in the one I want you to try, I want you to try this one. Px plus q power n equals minus 64 minus 96x minus 48x squared plus dot dot dot. And I'll also say, not that it really helps, that p and q are negative. I think there's two answers for each of them, so take the negative answer. Okay, try this one. Find p, q and n. See what you can come up with. Do it the same way, except just use n instead of, what was the last power? 5, yeah. Okay, let's have a look. I mean, if you're making progress, good. If you hit a block, it's okay.
Do you just leave it as MC2?
Nope. No, you can get number answers.
But MC2.
Yeah, I'm shocked too. So let's have a look at this. The first thing is writing this down. So if you wrote this down, that's already a good start. It's just the expansion with P, Q and R in it. Okay. Now we need to make some comparisons. So we know that NC0. Well, because the powers of x are ascending, so I need to match it up easily. Px0 is 1, so we have NC0 Qn. That should equal minus 64. Now, actually, you can, if you want me to write it out fully, it's like this. Equals minus 64. Turkey, why are you so late? Right, come back in 10 minutes. You're too late for the first class.
Yeah.
Come back in 10 minutes. Okay. Right. What was I saying? Yeah, this one here. So we can simplify this a little bit. What's px power 0? 1. And what's nc0?
1.
1. because the first column is always 1. So we have Qn equals minus 64. So this is like our first equation. Okay, let's examine the next one. We have NC1. Now actually I shouldn't have really written the x there, so let me just scratch it out. P1 Qn minus 1. That should equal,
N factorial.
what should it equal? It should equal minus 96, okay? Now, again, what's NC1? That's actually something we know.
N factorial.
No? It's N.
Ah.
Because when you think about the triangle, NC1 or anything C1, it's going to be the first column, and you'll notice that it always is the same as the row number. So it does. So if I go down to n, I know that the next one will be n. So I know that it'll be n. So that's good. And this is a P, and this is a Q, and that's a minus 96. Okay, so that's okay. The next one, the NC2, is the tricky one. That's the tricky one. Okay. Question yet? Yeah. Technically no, because there's two unknowns. And we don't actually know what each one is, but I get your point. We can have a pretty good guess at what's it going to be, because if you have a something and a power and the answer is minus 64, that you probably know the cube might be a 2 and the n would be the power to make 64, but we don't know that for certain, because this cube could have been any number and this n could have been any number, and there are many combinations to make 64. You know, I never said in the question that P and Q need to be integers. So if they were integers, we'd be finished. But because they could be anything, we're not actually finished. Yeah.
Like theorem, you take out the x.
We're just looking at coefficients, comparing coefficients. So we don't need to bring the x into it. I'm looking at just the coefficients. Yeah. Even if I did bring the x in, they would cancel on both sides. So it doesn't matter. Okay, so let's have a look at the third one, which is the tricky one. We have NC2 P squared Q n minus 2. That should equal minus 48. Yep?
Yep.
Okay. NC2, we can
N times n minus 1.
we can do something with the NC2. Let me go to the side for a moment and see what we can do with the NC2. So, the NC2, at least we know it's n factorial over 2 factorial n minus 2 factorial, using the formula. So on the top it'll be n multiplied by what comes after n? N minus 1, n minus 2, n minus 3, etc. until I get 1. And then on the bottom, I'd have 2 and 1. And then this one would be times n minus 2, what's next? n minus 3, etc. until I have 1. Now that's actually really nice, because a lot of things cancel. So you're just left with n times n minus 1 over 2, which is n squared minus n over 2. So it's not great, but it's something, if you want to write this down. So we can replace the NC2 with this quadratic. Or if you really want to make it a quadratic, you could write it as a half n squared minus a half n. Okay, going back to the right. Okay, going back now. So n squared minus n over 2. So for the third one, we can make it as, what did I just say? N squared minus n over 2. But I'll just bring the 2 up to the other side maybe. P squared q n minus 2. And I'll bring that 2 up to the other side. What's that? Minus 96, isn't it? If I bring the 2 across. This was n squared minus n over 2, so I just brought the 2 up to the other side, just so I don't have fractions, because nobody likes those. Right, 3. Okay, so I'll just give you 1 minute to have a look at these 3 equations, and then somebody maybe can suggest how I can put them together to get the answer, okay? Because we have 3 equations and 3 unknowns, p, q, and n. So just take 1 minute to have a look at these and think about how you can put them together. And if it helps, I can give you a little hint here. We haven't done these rules yet, but I think with powers, I think some people know it already. Like if I had x n over x m, that would be x power n minus m. So my little hint for you is to think about it backwards. If I said, for example, p a minus b, you can also think about that as p a over p b. That's my little hint, okay? I think that might help you to think about it this way. No, think. Yes. Siri can't help you here.
I got 1 step.
You have 1 step.
Yeah.
Okay, good, yeah. Right, so what's your 1 step to do then?
Is to separate q power n minus 1 into q power n times q power minus 1 and replace q power n with minus 6 as well.
Okay, hang on, let's have a look here. Let me just make some space here. Right, so what I'm going to do, well, this is what I was thinking of doing. The first equation, we can keep it as q power n equals minus 64. The second equation, I'll rewrite it as np qn over q power 1 equals minus 96. And the last equation, n squared minus n, that would be p squared qn over q squared equals, oh, that's also minus 96, is it?
Yeah.
That's a coincidence, right?
N minus 2.
The n, which one?
The q
I just separated the qn minus 2 into qn over q2. Using the trick I showed you on the side. Yeah. Now actually, because there's a p squared here and a q squared here, I might as well put them both together. So on the next one, I'll keep the first one the same. The second one I'll write as np over q, qn equals minus 96. And for the last one, I'll write it as n squared minus n, p over q squared, qn equals minus 96. Okay, so maybe things now start to seem like they're falling into place because qn equals minus 64. So I could put that into the second equation and make n p over q times minus 64 equals minus 96. Yeah. Okay, so that's good. And then I can say p over q equals, well, the minuses cancel, 96 over 64n from that. Just divide by n. Now, what do you think I might do with this answer?
Take the 1 by n out.
No, what can I do with this answer? Yeah, I can put this in here for p over q. And what about the q power n? Do I know what that is?
Yeah.
Yeah, that comes from the first one. So if I substitute both in, I get n squared minus n 96 over 64n times minus 64 equals minus 96. Now that's really nice because a lot of things cancel. What cancels? Well, we can cancel the 96 with the 96, the 64 with the 64. So we're left with the rather simpler n squared minus n over n equals minus 1. No, the minuses cancel as well, so just equals 1. This minus cancels with this minus. Now what type of equation is this?
Quadratic.
The quadratic. N squared minus n equals equal to n. So if I take that to the left,
n squared minus 2.
n squared minus 2n equal to 0. So this is n times n minus 2 equals 0. So you have two choices here for n. Which do you think it is? 0 or 2? N equals 2. Yeah? Yes? No. That's a lot there. Now that we have the n, we could work out the p and the q. Yeah. This was like 95% of the work, but don't worry, I won't. I just wanted to get to the end because that was the hard part, okay? This, of course, you are an expert at this. This is why you can afford to talk as I'm teaching it, yes? No, so don't. So here, I must have looked at your hologram talking then, not you, right? You were talking, I don't care what it's about. Yeah, but I saw you. He got lucky, but he got lucky this time. He got lucky this time. Next time maybe it'll be him, okay? You got lucky this time, okay? Dude. Right. Now, here we got to the end. This is too difficult for the exam, okay? The only reason I'm doing this is to just get you very comfortable with dealing with this, okay? But this is too difficult for the exam. But the previous example that I did, where the n, you didn't have to find the n, that would be of exam level difficulty. This is more difficult than the exam. But I believe in teaching during class to a level slightly higher than the exam, because then that way the exam will feel easier. The alternative would be to teach to a level below the exam, and then that will make the exam feel harder. I think you agree the first choice is better, right? Yeah. So we can write this one down, and then we'll have a look at the test, okay? So if you just want to write this down, and the test is on Moodle, so if you just want to take out your phone or laptop then. The test is open book, so you can use your notes for it if you want. Yeah? Didn't sleep? Life is tough. Life is tough. So tough. Yeah.